Space, vast, uncharted space. Man has looked to the heavens since his beginning and wondered, is Earthman alone in this great, awesome universe? If not, who else and where? The early man stared into the starry sky and saw very little, at least little that he could understand. But each generation had its curious who said, I wonder. And the results of their wondering were left for the next generation to use. Each discovery, each bit of wisdom became a stepping stone for those who came after. The telescope suddenly thrust man's sight far out into the sea of stars. From the knowledge passed down by all the generations before him, man began to reason over his universe, and from it came more progress. But one stepping stone, and probably the most amazing of all, one responsible for many of the wonders we have today, is the discovery and mastery of the tiny, invisible, yet all-powerful electron. Many call it the greatest discovery of the 20th century, unlocking the door to some of mankind's foremost achievements, as well as many promising opportunities for young, ambitious persons. For it is the little electron that has made possible the development of radio, television, radar, the guided rocket, the wonderful machines of the industrial world that operate almost as though they think, the guidance of giant airliners and ships at sea through fog and darkness, and many other spectacular developments, all of which has led to one of the most interesting, varied, and expanding fields of opportunity of our time, with the near future even more promising. Now, fresh from one victory after another, the electron stands on the threshold of one of its greatest triumphs. It is the science of electronics that is vital, in fact, that provides a key to man's coming exploration of outer space. It is electronics that is helping to probe the mysteries of the universe beyond, that is relaying vital information back to Earth. It is electronics that will provide guidance in flight and instant two-way communication between all points in our universe. It is electronics that will help analyze, weigh, measure, test, check, and safeguard man's leap into the unknown. It is the miracle of the little electron that will help make possible the bright world of tomorrow, in which space travel can be so much a part of our wonderful way of life. Yes, man is on the threshold of stepping off into space and finally seeing what he has wondered about for so long. Scientists have planned the timetable, the stepping stones into outer space that can now be foreseen and predicted. In fact, some of these steps have already been taken. No longer is space travel the dream of the science fiction writer. Unmanned, instrument-carrying, rocket-driven missiles have already entered stable orbits around the Earth, circling our globe just like the moon. And what does man learn from these Earth-circling satellites? The science of electronics has teamed with the new science of astronautics, making it possible to send knowledge back to Earth for man to evaluate. Delicate electronic instruments record on tape much data on temperature, atmosphere, meteorite activity, cosmic radiation, and so forth. This is relayed back to Earth by radio, where it is again recorded on tape and used to help make other steps on space travel possible. But more than that, such electronically equipped satellites will aid man in many ways right here on Earth. Navigational satellites put in permanent orbit at a height of about 1,000 miles will circle the Earth in approximately 2 hours. At this distance, a huge silver plastic balloon will reflect sunlight and be clearly seen and recognized, or be picked up by radar in any kind of weather, and thus be a valuable aid to ships at sea, airliners, or others at any point in the world. Once the balloon is put into orbit and the exact time it takes to circle the Earth is learned, then tables are drawn that tell a navigator his exact position according to the time and day he locates the satellite. It has been estimated that in the United States alone each year, $2 billion are lost due to faulty weather forecasting. This is not the fault of the forecaster, for he has reports on only 5% of the Earth's surface at any one time. But with a Weather Bureau satellite 4,000 miles out in space, equipped with a color television camera, about 40% of the Earth can be viewed at one time with complete coverage every hour or so. As a result, accurate calculations of the weather pattern can be made. Thanks to electronics, the practical and financial value of a weather satellite can be tremendous. Imagine a television program or a radio news broadcast that can be beamed more reliably to every place on Earth at the same time. Television waves, which travel well only in a straight line, can cover about 100 miles clearly without a relaying station due to the curvature of the Earth. But with only 3 satellite stations orbiting in what is called the 24-hour orbit at about 22,000 miles from the ground, a television broadcast can be seen in every inhabited territory on Earth. With each station spaced evenly 120 degrees apart above the equator, any one station can receive a telecast from Earth and relay it to the other 2. Then all 3 can beam it back to Earth. As fantastic as it all sounds, these are things we know now are possible. But as one authority and writer on rocketry and space travel put it, it is hard for today's adults who were brought up to think of a trip to the moon as something out of a Jules Verne novel to realize that this is not only possible, but certain. Let's see what the other stepping stones are that scientists have accomplished or have planned in order to make space travel a reality. With electronic equipped satellites orbiting the Earth, it's just another step to orbit the moon and other planets. And again, this step is possible only with the help of electronics and the many engineers, scientists, and trained electronic technicians responsible for rocket launchings who remain on Earth manning, recording, and interpreting the valuable information that is relayed back to them electronically. Manned single-stage rockets rising to heights of several hundred miles and returning to Earth by wings or parachutes. Such is man's next step and the first look into that space his instruments have told him so much about. With this new knowledge, it is possible for man to ride multi-stage rockets and enter orbits just outside the atmosphere, and after a few revolutions, return by rocket braking and air resistance. Before we progress any further, let's analyze the problem man faces in escaping the pull of the Earth's gravity. A good comparison is to think of the Earth as being at the bottom of a pit, thousands of miles deep. The pit being narrow at the bottom, with its sides curving outward as it rises, much like a funnel. The sides are steepest near the Earth, where the pull of gravity is the greatest. The problem is to climb this hill. In order to get out of this pit, a rocket must accelerate to what is called escape velocity, or 25,000 miles per hour. At this rate, a rocket will, if headed in the right direction, coast out of the pit into space, where it can maneuver relatively free of the Earth's gravity. One method of doing this is to blast off from Earth and accelerate to the required escape velocity of 25,000 miles per hour. The second method of doing it is to do it in 2 steps. The first step consists of so launching a rocket that it will reach a velocity of 18,000 miles per hour and guiding it into an orbit outside the Earth's atmosphere, where it will land on a space station previously placed in this same orbit. At this point, the rocket is not completely out of the pit, but is high on the rim, where the pull of gravity is less, as indicated by the reduced steepness of the sides of the pit. In the second step, a different rocket, or spaceship, is launched from the space platform and accelerated to escape velocity, thus driving it out of the pit. This second step spaceship is designed for more efficient operation in outer space than was the rocket which left the Earth. This brings us to another stepping stone, refueling manned multi-stage rockets in free orbit so they can circle the moon and then return to the Earth orbit. Now comes the big move, landings on the moon. Naturally, we cannot go into all the details necessary for such a move, but the basic plan has been established. With our space station completed, it's possible that the first spaceship to take man to the moon will be put together not on Earth, but at the space station, where, nearly free of gravity, the various parts can be more easily maneuvered and assembled into place. The advancements in the science of electronics and its trained technicians will help make such a project possible. In fact, it will be men and women, like you, who take training in today's well-equipped technical institutions, who will help play an important part in the fantastic new age of space travel. It will be those who are ambitious, who have an interest in such things as television and radio, who learn how electronic circuits operate, how to test, adjust, service, and interpret the results of today's marvelous electronic devices. We are fast approaching the time when man's first space station will be assembled, and his first spaceship will be ready to take off from that station for the moon. Since our ship is already traveling at 18,000 miles per hour, which is the orbital speed of the space station, it will require only 7,000 miles per hour additional acceleration to reach the speed that will take it over the rim of the Earth's gravity pit and coasting on its way to the moon, 234,000 miles farther on. At 24,000 miles from the moon, it will have slowed down considerably, but at this point, the gravitational pull of the moon on the ship is stronger than the Earth's and begins to pull the ship toward the moon. It gradually gains speed until it approaches the moon's surface and would crash at a speed of over 5,000 miles per hour. Landing, therefore, becomes a serious problem, especially since there is no air resistance on the moon to aid in the operation. Not being able to air brake or parachute, the ship will be turned as if in a vertical takeoff and a rocket blast timed before landing so that the force of the blast will act as a brake. This will mean that enough fuel for both the landing and the takeoff for the return trip will have to be carried. It is possible that the entire operation of the takeoff from the space station, the landing on the moon, and the return will be automatic and electronically controlled by computers on the ship itself or by radar stations and observatories on Earth, sending correcting signals to the automatic pilot by radio. Up to this point in our story, man has only been practicing on Earth's natural satellite, the moon. Now he is ready to explore the mysteries of the planets. But all he has done before has been valuable. Not only can he apply what he has learned in getting to the moon, he may also use the moon as his launching site, a sort of fixed built-in space station to serve as headquarters for the next step to our known planets and beyond. It is believed that some of the same elements found on Earth will be found on the moon. So a fuel source may be waiting for us, somewhat like a huge filling station in the sky. One simple comparison proves the value of the moon as a takeoff point. It takes a launching speed of 26,000 miles per hour from the Earth to coast to Venus by the most economical route. but a launching speed of only 7,000 miles per hour is required from the moon. The establishing of a moon base would, of course, take time and would not be easy. Perhaps the biggest problem would be artificially creating conditions on the moon similar to Earth's atmosphere so that man could work and live. But with nuclear energy-powered turbines supplying plenty of electric power, air-conditioned and temperature-controlled structures can be built by space-suited workers. Solar heating equipment can be used to store up heat during the extremely warm moon day, which is equal in length to 14 Earth days, to combat the bitter cold of the equally long night. The temperature ranges from 212 degrees Fahrenheit above zero to about 250 degrees below zero. Soilless farming would be ideally suited for the moon. Plants supported on netting over tanks through which vital liquids flow and exposed to the sun in greenhouse-type structures can grow large crops very rapidly. Pressurized motor vehicles with large balloon tires could explore and work on the moon's surface. Their motors would be electric, operated by storage batteries, or perhaps turbines driven by rocket fuels. By ferrying equipment and technicians from Earth, and with the wise use of the elements and materials to be found on the moon, a major moon base for space exploration can be established. As an aircraft carrier floating in the Pacific is a common sight now, so may the moon as a spaceship base be to future generations. From this base, instrument-carrying satellites can set off for Mars or Venus, there to circle in orbit and radio back the needed information for the next big step: manned flights to and landings on the sister planets of our solar system. Yes, man's conquest of space promises to be one of the most thrilling chapters in the history of mankind. A chapter made possible to a large extent by the wonderful opportunity field of electronics, with its mysterious, almost magical power to hurl a signal through space with the speed of light. With man's present wisdom and knowledge, time, money, and effort will make space travel not only possible, but certain. What thrilling and exciting years lie ahead. For those with a knowledge of this fascinating science of electronics, the challenge is boundless. Electronics and exploration of outer space have already formed a close and vital partnership. One depends wholly on the other. Together they form a matchless team, a team that can unlock the secrets of the universe. And with it will come an expansion of scientific knowledge unparalleled in history. What seems impossible to one generation becomes elementary to the next. And when we look back at the last 50 years and see the vast new industries that have developed due to our growing knowledge of electronics and our trained technicians, we need only look into the next 50 years to realize that the science of electronics should literally have us out of this world, for that is where it's taking us. Never before in history has there been such a challenge to man as the conquest of space now presents, and seldom do we see so much promise of new opportunity. Just as any football coach, after conceiving and plotting his plays, needs a full squad of players on the field to put his plays into action, so do the scientists and engineers need trained technicians to put their plays into action. For example, a large percent of a modern airliner cost is in its electronic equipment. The squad of players needed to follow these electronic parts through from manufacture to installation and maintenance is tremendous. It's becoming even more so with the development of such space travel problems as guidance, tracking, telemetering, measurement, control, data computing, and so forth. It's been said often that we are coming into a push-button era. The days of space travel will truly be that, and much more. For back of those who push the buttons is this vast multi-billion-dollar field of electronics, with its great variety of opportunities for properly trained technicians. Here are interesting careers, good-paying careers, careers with a future. Increasingly vast amounts of electronic equipment must be designed, produced, tested, inspected, installed, operated, and maintained for this fantastic new era in which man is entering. Here are opportunities that exist today. In fact, behind the spectacular headlines of man's latest venture into space lies one of the most promising fields of endeavor. Opportunities that are well within the reach of ambitious young people with the proper technical training. Just as our grandfathers during the steam age and our fathers during the electric age benefited and prospered, we and our children can find endless opportunities in the electronic age. But we mustn't forget that space travel will provide only a small portion of the opportunities electronics is opening up. The future of man's search into space depends to a great extent upon those who are today training for an interesting and profitable career in electronics. Just as it is known that electronics is a key to space travel, so it is known that the properly trained electronic technician is the one who will help turn this key. The young man or woman who wants to keep abreast of the rapid advances in this vast field of electronics may prepare in well-equipped technical institutes under the guidance of experienced teachers. Here the student acquires a good understanding of electronics and develops his practical experience by actually working with many circuits and commercial devices found in the field. For the person unable to leave his home or job, effective laboratory-type home training is also available. Learning in spare time, the student receives up-to-date texts, valuable equipment, even visual aid training movies. Following this method, he receives a good knowledge of theory and increases his practical skill at a pace suited to his own needs. When trained, he's ready to take his place on the team that is bringing to reality one of man's oldest dreams, conquest of outer space. So it is that another of man's unknowns is becoming known. Another milestone has been reached, a stepping stone that, thanks to the help and wonders of electronics, is opening up the mysteries of outer space to the gaze and reasoning of thinking men for the use of all mankind.